Hey guys, NA Science here. Today we will see like just a resume of a paper that is not in English yet, is in Portuguese. Problems with general artificial intelligence or problems with AGI. And AGI is a specific type of artificial intelligence that is uh, the concept the concept is around a machine that can think. So it's not a normal AI. It's not a weak AI. It's not like Alexa or like Siri that you can talk, but obviously don't have the intelligence that we want here in this paper. So AGI is a particular field related to machines that can generalize intelligence, that can in quotes think. So that is the paper. For now it's just the version in Portuguese, but the abstract is in English already, and some things will be in Portuguese, but after that in English. So I will just translate. So the main thing here is, I will translate what is here. Created AI. Someone to create AI that can think is a powerful desire, but far from be done. And in this article, we will try to understand the problems related to create an AGI in comparison with low-level AI like Alexa. So there is this paper, recent paper, like it was published in February this year, and by Melanie Mitchell, and she tries to, in just like few pages, um, she made good arguments against AGI, against and the concept of intelligence in machines, and she argued in the way of fallacies. I think that is 4 or 5 fallacies that related to why AI is hard. It's hard to do AI that really can do the things that we think we will achieve soon, but it's harder than we think. And in the paper, I go with more detail than it is into the video, but it's just like that. Other paper related to be against AGI, like argument that AGI is not possible, is that of Ragnar vigilance in nature and why general intelligence will not be realized. The arguments here are weaker than the paper of Mitchell. They are like philosophy. They do not um, speak in a way that really have computational concepts as the main source of trying to build something like AGI. This paper is much like philosophy, and I think that the paper of Mitchell is much better in the way that it tries to be against AGI. It's not like bad to be against AGI. It's just a way of reason about the subject. But the thing is that in this paper we'll try to be like not just happy and funny about AI, but try to be true and try to not take the hype of AGI. Of course, we want robots that can think, but it's not so easy. So it's written here in Portuguese. How robots are amazing, but not intelligent. that is an example from Icube. That is a robot that is used in other labs to that you can program him to do things that in some sense relate to emotions um, and in quotes compassion. Like you try to build these robots called Icube to try to be like a little human, like a kid. Here just grabbing Pikachu for example. I think that you can buy that, but I think that they just sell to labs. But is a robot that you can program to try to um, uh, not be intelligent, but in some sense try to create something more human. And there is a paper uh, talking about that, talking about this robot in specific. There are other robots that in some sense try to be like that, um, like try to create something that really can talk and be like human in some sense, like Sophia. That's the robot that you see in YouTube and maybe in television, and like it's pretty famous, Sophia, and she goes even to talk shows and something like that, like Jimmy Fallon talk show. She she really is a good robot, but in the words of Ben Gorzo, this robot is just a theatrical concept. It's just like a theater that you see something and you believe it. But in some sense, she is really a smart robot, but she do not use intelligence, even if she says in the videos. The concept that we try to argue in the paper is that robots like Sophia, they really can't think. They are just um, machines that don't have the power to generalize intelligence in the way we do. Maybe a different way, but not in the way we do. So that is her sister. Is recent. I remember in the channel of Singularity. I will put in the description of the video. Ben Gorto and his friend of Ransom Robotics, I guess, um, talking with Grace like an interview. He is really a smart robot that is in some ways sister of Sophia and is more like to help in healthcare, and it is really a good robot. It's better than Sophia, I guess, in the way she talks and use the software of Singularity from Ben Gortzel thing related to AGI. So it's really a good robot, but the main thing here is that this robot is really a really good robot. In some sense, is a great achievement in the way that it's done, but it does not have intelligence. So let's just introduce integration information theory, or IIT, and in the terms of this theory, we argue, they argue that the capacity of integration of information in the brain can be um, demonstrated with an information concept called phi. So the Greek letter phi, and in this theory, like is the capacity of integration of information is phi, in the way that every uh, being, every animal and human in this world is capable of processing information in a degree. So cats process less information than humans, maybe less than dogs, maybe not. Cats are more as smarter like than a rat. A rat is really low in brain processing than a cat, or a cat is lower also than a monkey, for example. That is a type in the animal world of more capacity of integration of information. And the thing is related to machines, this capacity of integration of information in the consciousness view is zero. It does not have, like John Searle would say, individuality. It does not have is free in some sense like us. It does not have the concept of really privacy in the way that we choose things in without regarding anyone. If we want to choose something, we will choose. We are capable of taking our own decisions. It's something that robots cannot do. They cannot be, in some sense, autonomous in the way that they think. That is something that we could argue, but that is a concept that we want to introduce. So, take for example GPT-3. You see in YouTube from this video, for example, for Jack Soslow, two AIs talk about becoming human, and I saw the video, and even though it's a really great achievement, it's not truly intelligent. It doesn't. This is a theatrical demonstration. It cannot. In the concept of the Chinese room argument of John Searle that we are say about it in the paper. It is like it's possible to translate using AI. It's possible to make things that speak, like using transformers, jacks, and other things. The thing is, even though it's a good system, it really can talk with you. It does not know. It does not know what is really doing, because it does not exist. It does not have the concept of consciousness that we call qualia. The concept of really being an individual that can, in some sense, have privacy of the observer. Is a machine that need someone to really do the things that are doing, even though it's like autonomous in some sense. So that is the why the fee of these systems is zero. It does not have intelligence anyway. But we can argue that it's processing information. It's using algorithm to do something like translating or talking, generating speech, doing language processing and things like that. So we will try to determine to establish not using phi for humans or other beings like organisms, biological systems, but like phi with that I don't know the English word for that, but the phi with that symbol that is called theatrical phi or theatrical consciousness. So we can process information as biological beings, but that machines cannot, softwares cannot, so AI systems cannot. So, but they are processing information in some sense using a human-developed algorithm. In this case, for speaking in GPT-3. So this is like a theoretical concept that is establishing that they have a fly, a consciousness, but not like us. It's different. So it's like a brick with the concept that we can create a machine that is conscious. We really cannot, but we can, in some sense, do something like so theatrical that we believe that is human. So it's a separation from biological consciousness, from a robot capable of doing things that in some sense look like a human. That's the definition of AGI by Pei in the Journal of Artificial General Intelligence, or JAGI, that the capacity of a system, a processing system of information, of adapt itself in an environment while operates with resources and knowledge that are not sufficient, like they have to learn to like being in a new environment with new things, new language, new objects, and trying to adapt itself like we do. Like if you walk in a street and you see a car and it's far away, you can cross it. But if it is like a car really loud, fast, we'll say like it's better not cross it because just fear of this this car be so fast that go like crushes you. That's a way of saying that we can make in your brains really quickly the synesthetical ability of calculating the probability of I can cross the street or not in seeing the environment. And like a robot can do this, depends. Can he do this learning by itself? So that is the thing. AGI is the capacity, the definition of Wang. We really do more like this is the base, and we add the concept of theatrical consciousness to uh, computer systems, but that's the base, the definition that I really like and is really a good definition for AGI for forever, I guess. The basis of what AGI really means. So that is theatrical consciousness. It's just a theatrical feature, no? Like the test of Turing, for example, or other versions of the test of Turing. It's like it's really fooling you that is a human. So so we can say that each passes the Turing test. So if it's so theatrical that it's fooling you, that he's a human, not a robot. So it passed not the Turing test, but the theatrical consciousness test, the test of really fooling the human to believing that is not a robot but a human. So you can think like systems like AlphaGo, AlphaStar that plays StarCraft 2, that is from DeepMind also, um, OpenAI 5 that plays Dota 2. These systems, they really can do things that humans cannot. A normal human like me cannot go out of gold in League of Legends. It's really hard for me. But a computer system can if we training do the training correctly, like AlphaGo did, for example, using reinforcement learning and other processes like Monte Carlo. In some senses, that AlphaGo use it, so they can learn, but they cannot generalize intelligence. They do not know what Go is, because they are just a more complex calculator. Like if you see a calculator, you think that calculators can think? Of course not. But AlphaGo system, it can think. It's really not different than a calculator. It's just doing complex calculations in a algorithmic environment, but it's really just a fancy super calculator, a fancy system, but do not think. And that there is this proposition. We talk a little in the paper about computational neuroscience. That's a paper from Frontiers that of Gabriel Silva, and it's an amazing paper, really just talking about why we need more mathematical definitions and propositions in neuroscience. And I think that reinforcement learning and meta learning that we'll explain later are a good resource for AGI, but I think that we have to have more understanding about the mathematics related to what happens in the brain. And Silva even argues that we need to create new mathematics to enter this realm. And it's really what you have in computational neuroscience yet, with the definitions of Hodgkin and Huxley and other definitions related to the way that brain works in the sense of electronic concepts. It's really good, but we don't know, like, can we represent the spatial information in the brain in a manifold using like remaining geometry, like you use to explain some concepts in AI and deep learning. I saw some articles related to explaining using manifolds the AI in some sense. That is a really good tool to understand AI. I don't know if we can use topology to argue better how the brain works, or graph theory combined with topology. I don't know, but we need really new propositions related to how the mind works. And of course, if without a better understanding of mathematics in neuroscience, we cannot do AI, because really, like how people invented the camera, they discovered how the eye works, how light works, and with that two combined, you can create a camera, and then after a digital camera, because we can know how to store information, and that's what the brain do also. You can like take a picture with your eyes also, about like the features of the face of someone. There is a region in the brain related to recognizing faces on view one. Like, we can do things in real life like a camera, because we don't understand how the mind do. No, not the mind, like the eye do. We can breathe an arm because we know how it works. The like a cyborg arm, like a mechanical arm, because we know how it works, the articulations and stuff, but we do not know how consciousness works in a mathematical sense. That is why AGI is so hard, because it's a neuroscientific problem that's not solved. So unless it's solved, we cannot go beyond what we have right now. We can argue about philosophy and other things related to AGI, create theories of consciousness, but it's really like trash if you don't have a mathematical concept to really create AGI. And it's not just a mathematical problem, it's a neuroscientific problem, a biological problem that's not solved. The problem of consciousness, the hard problem of consciousness of David Chalmers that we just talked a little in the paper. So that's a really problem to AGI. I argue that meta learning is a good future for not just AI but AGI, by that paper of Kirsch and Schmidhuber, related to using metalearning with backpropagation. Metalearning is just learning to learn, is use the parameters of the system as a base for the all parameters learn. So it's a good concept that is related in some sense to what you do when you learn. When you do things yourself, you try to learn better. To like you playing music and you say, "Oh, I just mistaking the notes," so I try to learn to not do that again, like correcting mistakes yourself without a helper. That is meta learning. And imagining use meta learning with reinforcement learning or imitation learning together. I think that is the future in some sense related to AGI, but not enough, because we reinforcement learning, we argue also the paper related to basal ganglia. We talk a little about that in the other video channel related to reinforcement learning, how the basal ganglia is related to reinforcement learning in the brain. But that's not enough, because to generalize them is not just reinforcement. It's really it's obvious that it's not just rewards. I do not smoke because I don't like, and even if you receive rewards related to things that you like, you may quit because you not like a reinforcement system. Just that you think, and if you want to stop thinking, it's not because the dopamine levels are high or low. It's just you want. It's consciousness thought. So the brain is not just reinforcement. So you have to use that, but not just that to do AGI. It's not enough. You have also to consider theories of consciousness. Archaea theory and integration information theory that I cited earlier are the best for me right now. And this paper of Oxford Journal of Neuroscience of Consciousness is a journal focused on that, and this paper is really good, comparing theories of consciousness, why it matters, how to do it, and they say that I don't know, global space theory and integration information theory are the most um, accepted theories, but it's really just theories. They are not proven yet. So unless you have a theory of consciousness, not just mathematical one, but a biological one that you do experiments and testings. If you have something that like that in the future, we will be able to progress a little more in AGI. But these theories are just theories. They do not have a basis yet. I like integration information theory. I like Archaea theory for Penrose and Hameroff. We cited a little in the paper, but it's just we do not have the biological test yet, experiments that you can say Archaea theory works. Like that consciousness happens in microtubules. And I think that can happen. Microtubules are in dendrites of each neuron. It really is like in all the brain. It really can maybe create consciousness thought in related to chemical properties, quantum quantum effects, and the chemical bounds of the our cognitive capability of microtubules. That is Archaea theory in some sense, but it's really does not have biological proof yet, so you cannot use it to create a system. that use maybe some concept of that theory, and that theory says that AGI is impossible also. The theory in some sense makes AGI impossible. You cannot use quantum quantum information to like create a system like AGI, so would make things a little harder. Things in the quantum world is just hard. So it's better take the classical step with the integration formation theory if you like AGI. Archaea theory is really don't like AGI so much, I guess. That is the concept of neuromorphic computing, like the chip Loihi of Intel, that is of the IBM also. And of course, neuromorphic computing is more based on the brain in some sense. Just take the synapse, then the dendrite axons that imitate some sense. The synapses is a really pretty architecture, and it's doing things already. Like I saw something in random recognition in the paper, not that paper, it was in other, but neuromorphic computation is really a future, but not yet. We don't know if it will be the future of AI, like combination with hardware and theories of consciousness plus other AI, more neuroscience based technology plus mathematical neuroscience, more deep thoughts in that. All this together maybe will be a better way to creating an AGI. And that hardware thing is really cool, but we don't know if it'll be better, like if you're better than classical computing, because this is not von Neumann computing. It is using a main register type of memory related computation. Is different than von Neumann computing, so it's not the classical computation that you'll have in other computers, cell phone and stuff like that. So it's new, but it's a good way of starting. That is this paper, Neuromorphic hardware learns to learn, is like Metalearning, so the hardware. This is also like a good step in that, and that is it. The problems with AGI, some things are like in Portuguese. I sorry for that, but it's just like a resume of the paper, and that's it. Bye.